Hi everybody, welcome back to chemistry. We're going to get started with today's target, which is to talk about, some covalent molecules and just what do they look like. Basically, by the end of today's lessons, you want to be able to draw what I would refer to as a level 1 or a more basic molecule and be able to identify those molecules' shapes. Real quick, let's just kind of talk about why molecules form the shapes that they do. It's because of this thing called VSEPR theory. It stands for valence electron shared pair repulsion, but the big thing that I want you to understand is that VSEPR means electrons don't like other electrons, kind of like magnets. Opposites attract and likes repel. Electrons are negative. They don't like other negative electrons. Negative are like, so like repel each other. The electrons are trying to be further apart from each other. And so because of that, when molecules form, they're going to make shapes where the electrons are as far apart as possible. We're going to be talking about CO2, and I'm going to be showing you how these atoms and the bonds that make up these atoms and the electrons in those bonds are as far apart as possible, and we'll talk about what shape CO2 is when that happens. Okay, there are two different ways that we've learned how to draw these molecules. We've learned with the electron dot molecule as well as the structural formula. So let's just quickly kind of recap how both of these methods work. With the electron dot method, we've got our valence electrons. Carbon has 1, 2, 3, 4 valence electrons, and oxygen has 6. 1, 2, 3, 4, 5, 6. And there are 2 oxygens. 1, 2, 3, 4, 5, 6. Cool. Okay, so since oxygen has 6 valence electrons, it needs 2 more. So it's going to share 2 of carbon's electrons. And since carbon has 4, it's going to share some of the oxygen's electrons. And when that happens, we can see that we're creating 2 double bonds because we're sharing 2 pairs of electrons. So there's a double bond right here where we're sharing these 2 valence electrons. And there's a double bond right here where we're sharing these 2 valence electrons. Okay, so how do we draw that with the structural formula? We just draw our atoms like we normally did before, but instead of all of these dots and circles and everything, we just draw some lines. A double bond here and a double bond here. And we also draw our unshared pairs of electrons. 1, 2, 3, 4, 1, 2, 3, 4. And there you have it. That's our structural formula for carbon dioxide, for CO2. Okay, so why did it make this particular shape? Why did we draw it like this instead of having it be like at an angle or something like that? Why is it a perfectly straight line? Well, it's because of VSEPR. See, electrons don't like being near each other. Kind of like the hogs in the hog Hilton. Hogs don't like being near each other. Electrons don't like being near each other. So the electrons in these double bonds are going to be as far apart as physically possible. If this molecule is slightly bent, that would mean that the electrons in those bonds are closer, and we don't want that to happen. We want them to be far apart. Okay. All right, so it creates a straight line. What shape is this? This is what we would refer to as a linear shape. And it's called a linear shape because it's a straight line. Makes sense. Go ahead and try N2. Draw the electron dot structure, draw the structural formula, and try and identify what shape N2 is. You can pause the video. When you unpause it, I'll go over the answer. So let's go over the electron dot structure for N2. We've got a nitrogen atom and another nitrogen atom. Each nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. And since they've got 5 valence electrons, they're going to get 3 more from the other. So there's 8 for the first nitrogen, and there's 8 for the second nitrogen. When we do that, we can see we've created a triple bond because we're sharing 3 pairs of electrons. And we've got an unshared pair on both of the nitrogen atoms. And just like the carbon dioxide molecule, we can see that this has formed a perfectly straight line, so the shape is linear. In my next video, we'll be talking about another shape. See you then.